All right, so we've been solving systems. Um, so what we're going to do today, we're not going to do graphing because we did graphing the other day, and graphing is the least efficient way to do this. So you won't have a lot of graphing systems that you'll have to do just because of how, especially if it's an equation. Graphing though sometimes doesn't give you a really good answer because if the answer is a whole number, if it's an integer of some kind, then it's fine. But if it's a fraction or a decimal, graphing is not a good answer because it's just hard to see the number that's there. So most of the problems we're going to do the solving systems with one of these two ways that we're looking at here, because we're going to do it by either the addition method or elimination method. So some books call it the elimination method. I kind of like the elimination method. Some people call it the addition method. Or by substitution. All right, and usually everybody has one of these that they like better. But when you're going on into pre-cal, there's certain times in pre-cal where you can do elimination and not do substitution, or you have to do substitution, but you're not able to do elimination. So you kind of have to at least be familiar with both of them because there are times in pre-cal when you have to do one or the other. Sometimes you can do both, but sometimes now you could do, if it says do substitution, you try elimination, you could do it, but it would take you four times as long to try to do it, and you'd have to get really creative. So, you know, sometimes it's good just to kind of have both of them in your back pocket, just because of where you're going in pre-cal next. So, okay, and again, if we're looking at the system, it's basically just that it's two or more equations with two or more variables. And again, we were graphing systems the other day where you had two lines. You can do that. You can actually have more than two lines that you're working with, but most of the time here in the beginning, we're going to stick with two lines with two variables. Okay, and we'll show you the addition or the elimination method first, and then we'll come back and show you substitution after that one, just because no particular reason, as we go through this thing. All right, so to solve by elimination, or again, some people call it the addition method. You add the equations together. To eliminate one of the variables. Okay, and that's why it kind of goes back and forth because some people say, well, we're adding stuff together, and then some people are like, well, we're eliminating the variable that we're going with it. But sometimes you could technically make it subtraction. You could subtract the equations together to eliminate one of the variables. So I kind of like elimination because you're just trying to eliminate one of the variables that you have there. Okay, so after you add these two things together and you eliminate one of the variables, after you find the value of the first variable, so you're going to eliminate one variable, which means you've got one variable left over. And after you find the value of that remaining variable, then you plug that value into any of the originals. So plug that value into any original equation to find the value of the other variable. Because again, what we're doing with these systems is you're still trying to find, again, if you think about what we're doing when we're graphing these, we were trying to figure out where these two lines would cross. So you're still looking for an ordered pair. So if you find X, you still got to go back and take the X value and plug it back in to find out what the Y value is. Or if you find the Y value, you've got to go back and plug it back in to figure out what the X value is going to be. All right. Now, sometimes people go, well, what are we doing here? Here's what you're looking for when you have these systems. You want the same number. We're talking about the same number. We're talking about coefficient. If you want to get the technical word over here, so you want the coefficient on the same variable. So same number on the same variable in both equations. I don't know if I need a semicolon there or not. I'm going to put one. The difference is you want one of the variables to be positive, or one of the numbers to be positive. And then one is negative. So if one number is 4x and the other number is negative 4x, if you do 4x plus negative 4x, you get 0x, which means the x is now 0. It's just because you do 0 times x is 0. So the x variable is gone. All you're left with is the y variable. Okay, so if we take this example we had back up here and just rewrite that one, we'll use that for example 1. And usually they'll tell you just to solve. We got negative 2x plus 8y equals negative 8. We've got 5x minus 8y equals 20. Okay, and it's not as big a deal now, but because when we get three variables and three equations, it's a little bit more important. But for just right now, out beside it on the end here, I'm going to just put E1 and E2. And again, it's not a big equation one, equation two. It's not a big deal now, but when we do the three equations, three variables, it will be more of a big deal then when we start looking at it. Okay, so again, what we're doing is, pull this down a second. We want to have the same number on the same variable in both equations where one's positive and one's negative. If it is, it's great because now we've got a positive 8 and a negative 8. So then all we've got to do is just add these two equations together. So that's negative 2 plus 5, or 5 minus 2, so that's 3x. You've got 8 minus 8, which is 0y, which is what we want because now that's just gone. That's a 0. So it's 3x plus 0, which is just 3x, equals 20 minus 8, which is 12. All right. If you got 3x equals 12, pretty easy, right? Just divide both sides by 3, and we got x equals 4. All right. And again, what we're doing over is we're trying to figure out, if we graph these two lines, where these 2 points are going to cross. So what we know is right now the x value is 4. We've got to figure out what the y value would be in this equation when we do this. So what we're going to do is we're going to take this 4 we've got here and just pick either one of the two equations and plug it back in and see what number you get there. Doesn't matter which one you plug it into. We're just going to plug this thing back into equation 1. So we got negative 2x plus 8y equals negative 8. And again, it doesn't matter whether you pick equation 1, equation 2, just pick one of them. We're going to plug the 4 in here. So that's negative 8 plus 8y equals negative 8. A lot of 8's there. We got the y over here, so I'm going to add 8 to both sides. So that's going to leave us with 8y equals 0. And if you divide by 8, that's still just y equals 0. Okay. And again, if we're doing this paper pencil wise, the final answer I'm going to look for is an ordered pair. So it would be 4, 0. And Math Excel is kind of nice because if you're doing this on Math Excel, they either give you X in a blank and Y in a blank, or they give you an ordered pair and you have to fill in the ordered pair. So I think biggest thing is just make sure you get both values. Sometimes people get here and they're like, "Woo! I got my answer, I got my X," and then they stop. And I'm like, "Well, that's fine, but remember, we're basically graphing this thing, so you're looking for an ordered pair of where this answer would be. So make sure you got both parts of it that you go through this thing." All right, everybody good there? Anybody got thoughts or questions? All right, so let's do this. Let's give you another example where you got to tweak it just a little bit. All right, so example 2, here we go. All right, so with the x's, now again, we've got it close here because we've got the same number, but they're the same sign. So if we just put this thing together and add it, we're going to get 6x, we're going to get 2y, and we're going to get 4. We're not going to eliminate any variables if we just do it that way. So you got one of two options. And this is where sometimes people say, well, let's just subtract the two equations. You can do that, but just kind of from a standpoint of teaching this for a while, I realize that people are better at adding than they are subtracting. So let's don't do subtraction in this case. So what we're going to wind up doing is we're going to take this bottom equation, and instead of subtracting it, we're going to take everything in this bottom equation and multiply it by -1. So the good thing is when you go through these, you can multiply either or both equations by any. Now you have to kind of say, used to not say this, but I'll say it now. By any non-zero number, because people say, I'll just multiply by 0, it makes it real easy. No, you can't do that. It's got to be a non-zero number. To help with elimination. Because as we go through the problems here, everyone we get, you're going to have to start multiplying some equations to help make it work out to be what it's going to be. It's not always going to be as easy as, okay, here's all the numbers and it's perfect. You're going to have to start kind of adjusting these. So, okay, so for this one, we're going to take this second equation and multiply it by -1. So we're like, well, does it have to be the second one? No, we could have taken the top equation, multiplied it by -1. It doesn't really matter. You just pick one of the equations you think would work, and then we go with it. So, all right, so the top equation, we're going to leave it just like it is. Bottom equation, multiplying by -1, you just change all the signs. So that's a -3x, that's a -6y, and that's going to be a +8. Okay, so taking that second equation, multiplying by -1. Now we've got the numbers that we're looking for because you've got 3 minus 3, which is 0, x, which means that's gone. You've got -4 minus 6, which is -10y. 12 plus 8 is 20. And then we'll divide both sides by -10. So now we know that y is going to equal -2. Okay. But again, that's halfway because we've got the y value. You've also got to figure out what x is going to equal. So we're going to take that y equals -2. And again, just pick either one of the two equations you want to plug it back into. Doesn't matter. I think on the last one we picked equation 1. So this time, just to do something different, let's plug this into equation 2. Now, we didn't label that back up here, and I guess we should have done that. This is equation 1. This is equation 2. Again, with two equations, it's not too bad because you can just say top or bottom and know what we're talking about. In this case, we'll kind of label it that way. Okay, so we're going to take that y equals -2 and plug it into y in equation 2. Okay, and then just work it out from there. So that's 3x minus 12 equals -8. We're going to add 12 to both sides. Okay, and now don't freak out because somebody's like, that doesn't go evenly. It's a decimal answer. It's got to be, no, it's okay. Because when you divide both sides by 3, then we get x equals 4/3. And if you get a fraction, it's okay to have a fraction answer because sometimes that's going to happen. If you're like, well, that can't be right because now, if you want to double check, if you plugged in equation 2 and you thought that was the wrong answer, then go back and plug it back in equation 1. If you do, you should get the same answer, and that should hopefully kind of, calm your fears a little bit. So now you won't get a lot of fractions, but you will occasionally get some fractions as you go through these. Up a notch here. Let's go 3x plus 2y equals 6. And 6x plus 5y equals 12. All right, so example 3. This is probably a few more of the problems you're going to see because on this one, you don't have the same numbers. So that means you're going to have to do some work on these to kind of match it up. Okay, now there's not a right or wrong way, but there is some times on these that will be easier than doing other ones. Is there now? And basically, you look at this one. Is there an easy way? Is there a whole number you can multiply to go from 2 to 5? You can do decimal number, right? But we don't want to do decimals. Can you multiply to go from 3 to 6 with a whole number? You can, right? So if we just take this top equation we've got here and multiply it by 2, we'll have 6x and 6x, and we're good to go. Okay, now here's the check you've got to do. And here's kind of where you want to make it so you don't have to do double the work as you go through these. If you multiply this equation by 2, you're going to have 6x, right? The bottom row is already 6x, right? And we said when we're doing this, you need to have different signs. So if the bottom equation is already positive, because we're not doing anything to the bottom row, we're not doing anything to equation 2. If this one's already positive, this one needs to be negative, right? So instead of multiplying by 2, just go ahead and multiply by -2. And that way when we multiply by -2, now we've got a -6 that's here. So if you get ready to do elimination and you've got your numbers and you look at it and you go, well, they're both positive, instead of multiplying by +2, just multiply by -2. And that way it's already kind of 2 steps into one that you've got everything lined up there. So that's -2 times 2 for -4y and -2 times 6 for -12. All right, so I'm already hearing some zeros out there. So 6 minus 6 is 0x. That's out. That's gone. 5 minus 4 is 1y equals 0. And there you go. We just got y equals 0. Okay. And again, just pick one equation, plug it back in. Doesn't matter. We're going to go back into equation 1. So that's going to be 3x plus 2 times 0 equals 6. Well, that's just 0. So that's 3x equals 6. So then x equals 2. Okay. So far, so good? Everybody comfortable? All right. Here's the worst possible scenario you could get. If you can do this one, you can do any problem that pops up on this thing. So right now, y'all probably done, I don't know, 75% of everything you can see. And we'll give that last 25% here. So we'll go negative 4x minus 3y equals 5. And then 3x minus 2y equals negative 8. Okay, so all you're going to do for the variables is you're going to look and see, can I multiply to go from 3 to 4 with a whole number? No. It's going to be like 1 1/3 or 4/3. You know, when again, we don't want fraction because it's going to throw everybody off. Same thing here. You cannot go from 2 to 3 or 3 to 2 by just a whole number. So in that case, you're kind of stuck because there's not one number that you're going to be able to multiply by to get rid of these two variables, either one of them. So if that's the case, then you're going to have to multiply both rows.
Yeah.
Or both equations, I guess we say it that way. All right. Now, here's what you can do. Probably the easiest thing to do is, and you can pick the y's, but to me, the easiest thing to do is pick the x's, is what's the first number that 4 and 3 have in common, if you think common multiples? Be 12, right? So basically, here's what you can do. You can just swap these numbers, take the top row, multiply by 3, take the bottom row and multiply it by 4, and then just see if we need to throw a negative in there somewhere or not after you kind of set up your numbers. So just throw in the numbers without the signs. Just switch the signs or switch the numbers. So that way we've got 3 times 4 for 12. We've got 4 times 3 for 12. So if whatever these first two numbers are, if you just switch where they are and multiply, you'll always get it so that you can eliminate that first variable. Really easy without having to do a lot to it. All right, so everything times 3 here is negative 12x minus 9y equals 15. Okay, and then we're going to check the bottom. We've got 4 times 3 is 12x. And that one's good because if we just switch these two numbers, that one's negative 12, that one's positive 12. We don't need to throw any negatives in there to throw this thing around because this one's already negative 12 and that one's positive 12. So people are like, what if I put a negative here on this one and I make that a positive 12? Well, then you need to put a negative here on this one to make that one a negative 12. So just kind of, play around with the signs till you get them to work out to be what you need there. This one, we didn't have to do anything with these signs. So we got minus 8y equals negative 32. Okay, putting those together, that's 0x. That's what we want. That one's gone. We got negative 9 minus 8. Be careful with your signs there. That is a negative 17 equals negative 17. And then dividing by negative 17, that means our y value is going to equal 1. Okay. Now, and you can take this 1 and plug it back in here or plug it back in here to then figure out what it's going to be. But the numbers are just going to be bigger. Most people don't like working with bigger numbers if you don't have to. So we can still take this 1 and plug it back in somewhere up here to figure out what it's going to be. Again, no particular reason. Just pick one you think that you would think would be easier. Last time we used equation 1. This time let's just use equation 2. So that's 3x minus 2y equals negative 8. And we're going to plug in this 1 right there. All right, there we go. So that's 3x minus 2 equals negative 8. Add 2 to both sides. X is negative 2. Okay, so if you can do that, that's as bad an equation as you're going to look at. All right, so next part, we're going to do substitution. Okay. All right. So substitution is a little different because it's more of a three-step process, I guess, that you have to kind of do, and it's one of those things where you really only need to do substitution, and you don't have to do substitution. You can always do that, but it's good to at least have it there. It's only good to do substitution if they've got step one done for you. So let me show you what step one is. Okay, so step one is you're going to solve one equation for one variable, and when you're going through this one, you want to look for a variable that's got a coefficient of one. So that basically you've got either x or y without a coefficient. I mean, because technically, if it's no coefficient there, then it's understood to be one. And I would say when you're doing these, you really only want to do substitution when step one is done for you because it without that it kind of slows the process down a little bit. All right, step two is where you actually do the substitution here. All right, you're going to substitute the equation from step one and I guess the easiest way to say this is we're going to substitute that into the unused equation. Because right now we've taken one of the equations and solved it for one variable. There's one equation we haven't done anything with, and that's the part we got to do the substitution with from there. And then after that, the rest of it is basically doing the same thing we were doing before. Now you're going to solve the remaining equation for the variable. Because now that you've plugged in or you've done the substitution, instead of having x and y, now you're just going to have either all x's or all y's when you go through that part. Okay, and then you're going to use the value found to then plug it back in to, and this is one where you want to go back and actually use your equation from step one. To then find the second variable. Okay, so step three, the last step you do is the same no matter whether you do substitution or elimination. It's just a matter of working around back this part back here. But again, I would say when you're doing these, if step one is not done for you, I would not do substitution. I would do elimination because it's probably going to be a little bit quicker and a little bit faster to kind of go through those. Okay, so we'll show you one where where step one's done for you. We'll show you one where it's not done for you and what you would have to do. But then we'll show you how easy it would be if we would do elimination instead of doing substitution for that part. So. Okay, here we go. So here's the first one. We'll have 3x plus 4y equals 12. And then y equals negative 2x plus 10. Okay. Again, this one would be one where they would tell you specifically to use substitution to solve it. Okay. So for equation 2, already has y equals negative 2x plus 10. So step 1 is done. Okay. And again, that's really when you want to do substitution, is that step 1 is done for you. So you don't have to do that first step. You've got y equals negative 2x plus 10. So then we're going to plug this thing into equation 1, because equation 2 is already done for you, which is step 1. And whatever equation you don't use, you've got to plug that back in there. So here's the thing. Sometimes people get a little bit confused with this one, and what you're doing is, and I remember doing this before with people, and I was like, okay, sometimes that if you actually just write it out with words, it makes a little bit more sense, and I don't know why. So for this part of it, we're going to replace y with negative 2x plus 10. So wherever you've got this y equals part, just think in your mind that you're going to replace y, take out the equals with, so replace y with negative 2x plus 10, because those two are the same things. So we're going to replace the y with negative 2x plus 10, and this is back in equation 1. So we're going to take equation 1 and we're going to replace y with negative 2x plus 10. So it's 3x plus 4 times negative 2x plus 10. All right. And again, I don't know why. For some people, if you write down those words, it will make it click. But sometimes I know we've had people in the past where I would do this and they would get it here and they're like, well, I'm confused. Where do I plug this back in and what do I do? So I started making people write it down. And when they would write it down, they actually were okay with that. So just wherever you get y equals, just think I'm going to replace that y with that expression that's there, and then work it out from there. Now, for some people who aren't, again, if it's been a year since you've been doing some of your math skills, this is why substitution is not always the best, because now you got to go back and do distributive property with 4. So now we got 4 times negative 2x for negative 8x, 4 times 10 for 40, and you've got your 3x there. And now you got to combine some like terms, because you got 3x minus 8x, which is negative 5x. Plus 40 equals 12. And then we're going to subtract 40 from both sides. We get negative 5x equals negative 28. All right. And again, we're going to get a fraction. We're going to get a decimal here. So we can divide by x. Now, in that case, sometimes they'll tell you to do it as a fraction. To me, that doesn't, we can leave it 28 over 5, but let's go ahead and just change that to a decimal. Let's just go ahead and make that 5.6. Okay. And this would be one of those questions where hopefully they would tell you to write this answer in decimal form, because it would just be a lot easier there. Okay, and now we're back to what we're doing on the last time. Once you've got the x value, you've got to take this x value of 5.6, and you're going to plug it back into one of these original equations. But for these, you always probably want to use this, whatever we use for equation 1 here, that we had for step 1, that's the equation you want to use, because it just makes the work a lot easier. So we've got y equals negative 2x plus 10. And we're going to plug in this 5.6 for x here. So that's going to be negative 11.2 plus 10. So that's going to be negative 1.2 for y. So let me give you one more of these, show you, we'll do one more with substitution, but then we're going to show you that even though they say substitution, I wouldn't do substitution in this case. I would do like we were doing with elimination. Now, unless you just like substitution. If you like substitution and that's your thing, go with it. But most people like doing the elimination or addition method better just because you don't have to worry about doing distributed property and combining like terms and moving stuff around. It's just the math process of doing it usually is a little bit easier when you do the elimination or addition method. All right, so for example 2. We got x plus 3y equals 5. And then negative 2x minus 4y equals negative 8. Okay, so we're going to use substitution, but then as soon as we get finished with substitution, we're going to redo the problem with elimination. And then that way you can kind of look at the two and see which one you think is easiest and then go with that one. Because some of the questions will say pick whichever method you want to pick, so you actually get to choose which one you think is best. Okay, so for this one, if they tell you to solve by substitution, you've got to solve one of these for x or y. And again, the one that's by itself, where you've got just an x here, let's take that equation and solve it. So we're going to solve equation 1 for x because all we've got to do is just subtract the 3y from both sides. So if we've got x plus 3y equals 5, we're just going to subtract 3y from both sides. And we got x equals negative 3y plus 5. Okay, so if this came out of equation 1, in equation 2, we're going to replace x with negative 3y plus 5. Okay, and that's kind of what you want. Again, to me, it just makes it a little bit easier to kind of think about what you have to do. If you get confused about what you're plugging in and where you go with it, whatever you solve for this first equation, you're going to plug this value into the other equation. And again, just think you're going to replace x with this thing over here because x equals negative 3y plus 5, so we can switch these two things in and out here. So for equation 2, we're going to take out x and replace it with negative 3y plus 5. Okay, and again, you have to do distributed property. So you got negative 2 times negative 3 for a positive 6. You got negative 2 times 5 for a negative 10. Minus 4y equals negative 8. If you want to add the 10 to both sides, now we've got 6y minus 4y equals 2. 6y minus 4y is 2y. And then dividing those two numbers, we get y equals 1. Okay, again, just so we got room all on the same page here. The easiest thing, again, usually to do is go back to this first equation, step 1, and use that equation. And we're going to plug in y equals 1. So we're going to take out the y, plug in 1. So x equals negative 3 plus 5, so x equals 2. Okay, so that's doing that one the way they said to do it with doing substitution. But again, I would say for that one, because they didn't do step 1 for you, I wouldn't do if they gave me this equation and they asked me to solve it, I would not do substitution. I would go ahead and do elimination. And let me just kind of do that underneath it here, just so we can kind of see. Because if we take that equation that we have and do elimination with it, okay, because we got x and negative 2x and 3 negative 4. We could just take this top equation and multiply it by 2. So that would be 2x plus 6y equals 10. And the bottom equation would stay the same. So we've got 2y equals 2. We've got y equals 1. How fast was that compared to doing all that? Way faster, right? So if they don't give you step 1, I would say just ignore the directions. If they don't give you, y equals something or x equals something, I would say just skip that and just do elimination, because it's going to be a whole lot faster to then turn around and take this number and plug it back in. Plug in the 1. There you go. And that's just how fast you can get it that way. Okay, so there's your 2 options you can do. And again, some questions it's going to say just take your pick, do whatever you think is best. Some of them, even like this one, if it said to do substitution, I would not do substitution, because it doesn't really make sense to do substitution. Only if they give you something like this, you can do that. And some people say, what if I don't like that? What if I want to just take this equation and rewrite it so I could do elimination? You could still do that. If you did that for this one, you'd have to move this 2x from over here, and then you'd have your variables that would line up, and you could go that route. But again, if they already give you y equals, it's actually going to be quicker to do the substitution in that case. Elimination in that case would take a little bit longer, because that went through pretty quick. All right. Oh, now one last thing. We didn't talk about this. We kind of sort of did with the graphing notes of the day. But let's say you take this equation. Let's do a what if at the end here real quick. Let's say we had done elimination, we had done substitution, and we've taken, let's just take this equation we have back here. What if we had 2x plus 6y equals 10, and we worked this thing out, we had negative 2x minus 6y equals 10. So we're working out elimination, we line up our variables, and we eliminate x, and it's gone, and we eliminate y, and it's gone. So can we have nothing equal 20? Because basically this is 0 plus 0, right? If both of those are gone. What happens if we get 0 equals 20? There we go. No solution, right? So who's throwing that out there? Okay, here we go. So it's still going back to those things that we were doing before, that you may still get some no solutions on these. Because if you work this thing out and you check it and it doesn't make any sense, it means that those lines don't cross each other. You may also get one where if you work this thing out and you get to the end and you get like 0 equals 0, which may be that you have infinitely many solutions. So realize those 2 cases we were working with a while back when we were solving equations, how sometimes you would get those answers. Those 2 possibilities still pop up as you work through some of these problems. So you may still get some no solution and some infinite many as you go through these.